All right, in the next section, we have arrived to our very fun and exciting coordinate planes section. Who's ready for this? So mine's gonna look a little bit different than yours. I printed out a piece of centimeter grid paper just so that as I'm doing it, you could see it a little better and I don't have to zoom in and out so often. So I recognize that yours is a lot smaller, so you'll have to channel your inner small, tiny writer, because you will have to write small, especially the numbers that you're labeling, but you can do it. You can do it. Example 1 says, dinner service starts once the train is 250 miles away from Yonkers. What is the minimum time the players will have to wait before they can have their meal? All right, so the very first thing that we're gonna do is we're gonna plug our table in again, but this time we're going to include this column that says ordered pairs. So I touched base on what that means in our content goal, but ordered pairs are going to look like this. So you'll have your first number and your second number. They're separated by a comma and enclosed in parentheses. So hours per miles, again, it was 2 hours for every 100 miles traveled. So when I want to plug that in as an ordered pair, I go 2, 100, just like that. Okay, and I'm going to continue. I've got 4 and 200. Plug that in for 200. Okay, I'm just gonna make like a little note right here to remind myself that the train, the dinner starts once the train's 250 miles away. So the next numbers I plug in are gonna be 6 and 300 miles. So I'm gonna make a little note that train service starts right about here at 250. Okay, so I'm just gonna recognize that that's where train service starts, the dinner service. Okay, and then I'm gonna keep going. So 7, mistake number 6 today, 8, because it's increasing by 2 hours. All right, 8 hours traveled 400 miles. Okay, so 8, 400, and add another 2 hours, 10, another 100 miles, so 10 hours, 500 miles, just like that. Okay, so let's go ahead and start plugging this in here. So on yours, the first thing you want to do is take a look at what this coordinate plane is. So this vertical line represents the y-axis. So for us, that's going to be the amount of miles that were traveled. So we're going to label, do a little after that, miles. Okay, miles traveled. And then this x-axis here is going to represent hours traveled. You just put hours. So the first thing our coordinate plane would be 0, right here. My pen is not working very well. 0, because you travel 0 hours, you get 0 miles. Okay. I'm gonna recommend that since we're skipping by, we're skip counting basically, we're going up 2 hours. So I'm gonna skip a line in the middle. So I'm not gonna write on the first line, I'm gonna write on the second line, 2 hours, 3, 4 hours, 5, 6 hours, 7, 8 hours, 9, 10 hours. Okay, that's the farthest that we travel. Now say you were skip counting by like 5 hours, you wouldn't need to skip 5 spaces on your graph or anything like that. I'm doing it for a couple reasons today. Not only because this graph is so small, but you just want to make sure, the only thing that really matters is that since I skipped 2 spaces here, I want to do the same on this side. It's like 100 miles, I'm going to skip 2 spaces. 2 spaces to do 200 miles, 2 spaces to do the next number, 300 miles, 2 spaces to do 400, and 2 spaces to do 500 because we want it to be the same distance apart from each other so that we're able to plot and show a graph for these ratios respectively. So we're going to go ahead now and plot our first number, our first ordered pair on our coordinate plane. So our first ordered pair is 2 hours. So I'm going to find the 2, and I'm going to go up to 100 miles and see where they meet right here. So I'm going to plug a point right there. I could also start at 0, 0. The next one is 4 hours. I'm going to travel 200 miles. In 6 hours, we will travel 300 miles. In 8 hours, we will travel 400 miles. Make sure I'm doing this evenly. Okay, and in 10 hours, we have traveled 500 miles. Now, obviously, this is not representing the whole trip because the whole trip was 800 miles, but the table only gave us this much room, so we're just gonna stop there. Okay, and then I can draw a line to represent my graph here, my ratios, staying at the same constant rate. And the last part says, what is the minimum time the players will have to wait before they can have their meal? So, let's see, I can use this color. So we recognize 250 miles would be right here. So I'm gonna kind of look for where that corresponds with our graph. And it's right here, which means that they can have their meal at the 5-hour period, because in 5 hours, they would have traveled 250 miles. You also could have noticed that by plugging it in your chart. If it takes 4 hours to travel 200 miles and it takes 6 hours to travel 300 miles, well, 250 miles, that's exactly halfway in between 200 and 300, and 5 is exactly halfway between 4 and 6. But I also wanted to show you how that is represented on our coordinate plane as well. That number would be right here. So off to the side, I will write the players can have their meals after 4 hours. I'm sorry, after 5 hours of travel. Lesson summary: a ratio table, equation, or double number line diagram can be used to create ordered pairs. These ordered pairs can then be graphed on a coordinate plane as a representation of the ratio. Example, equation y equals 3x. So here, what we noticed, we've been talking a lot about a constant, and that's really why we started talking about equations yesterday too. Noticing that, for example, if this is x, I can find y by multiplying x times 3. So that's why it says here 3 times x would give me y. Okay, and that would work for any of these numbers. I could take, and you could see on the table as well. If you know one of them, you can use that relationship to find the other. If I wanted to find x, I could do 1/3 times y, like taking 3 and I multiplied that by 1/3, I would just get 1. Okay, if I take 6, I multiply that by 1/3, I would get 2. So that's why we started talking about equations yesterday and noticing those equation relationships, because they all correspond. Here is a coordinate plane. It shows that the graph, all along this graph, that y equals 3x, because the numbers in the ratio are all going to be multiplying the x by 3 to find the y in the coordinate pairs. This is something you're going to continue seeing. So it just shows you how all of these pieces fit together to represent data visually. The problem set today is just like the lesson that we did. So first you're going to fill out this ratio table, and it tells you the ratio already. It says for each pie, she needs 3 cups of sugar. So the first thing I would do, 1 pie, 3 cups of sugar, okay? And that allows you to fill out the rest of the table. It says use a graph to represent the relationship. So here, just a little starter. You're going to want to label which is which. So this bottom part here could be sugar, or cup, C for cups of sugar. And then going up, we've got pies. Okay, remember I recommend that you skip 2 lines just to give yourself some more space, but make sure you do that on this side as well. So 0, you know, this would be 1, skip 2 lines, 2 pies. Okay, same thing over here as well. Even though we know this first number is going to be 3, I can go ahead and skip 2 lines and just put my 3 right there. Skip 2 lines, there goes my next number. Just make sure there's the same amount of space between the y coordinates as there are between the x coordinates. You don't want to have that scale off. The second part of your problem set, well, really the second part of number 1, is asking you to just plug those in on the double number line. So pies, 2 cups of sugar. Okay, and then on number 2, write a story context that would be represented by the ratio 1 to 4. So you come up with a scenario. We've done this a couple of times in different problem sets this module. You come up with a scenario that will be modeled 1 to 4. For every 1 of this, there's 4 of that. Some type of ratio language. So you would write that out here. Complete a table of values for this equation and graph. Make sure you include your labels. Whatever you're talking about, you know, bracelets to necklaces, whatever, label which is bracelets, which is necklaces, or bracelets to total, however you have it. Just make sure you're labeling which is which, and then you'll go ahead and put that on your coordinate plane. Okay, there should be words labeled here and here when you plug it on the coordinate plane. And that is that.